Ever pondered over the question, how do rockets work? That's a question that has fascinated humankind for centuries. From the first wonderings of primitive cultures gazing up at the night sky to the modern rocket scientists of today, the mechanics behind these mesmerizing machines have been a subject of deep curiosity. Well, you're in for a treat today, as rockets are not just giant tubes that shoot into the sky. They are much more than that. They are symbols of our collective curiosity, our ambition to explore the unknown, and our relentless pursuit of knowledge. They are instrumental to our understanding of the universe. They've taken us to the moon, to Mars, and beyond. They've helped us study distant galaxies, search for signs of life on other planets, and comprehend the expansiveness of the cosmos. Rockets are complex machines, meticulously crafted and engineered for space exploration. Every single component of a rocket, from the largest fuel tank to the smallest screw, is designed with precision and purpose. Various teams of engineers, physicists, and technicians work tirelessly to ensure that these rockets are prepared for the harsh realities of space travel. Firstly, a rocket in essence is a vehicle. It's a vehicle not for the roads or the skies, but for the outer space. It's a vehicle defies gravity and propels itself into the cosmos. It's a vehicle that carries our hopes and dreams, our scientific pursuits and technological advancements safely beyond the confines of our planet. It's specifically designed to propel itself through the hostile environment of space. Space is not a forgiving place. It is a cold, dark, and vacuum-filled expanse. There is no air, no sound, and no life as we know it. The temperatures can be extremely high or low, and the levels of radiation can be lethal. In this hostile environment, a rocket is designed to not just survive but thrive, to carry out its intended mission successfully. By expelling mass in the opposite direction of its intended travel, a rocket defies the laws of nature that bind us to the Earth. This is a principle known as rocket propulsion, a marvel of modern science and engineering. Rocket propulsion involves the combination of chemistry, physics, and thermodynamics to create a force capable of overcoming Earth's gravity. This concept traces back to Newton's third law of motion. For every action, there's an equal and opposite reaction. This fundamental law, stated by Sir Isaac Newton over 3 centuries ago, forms the backbone of rocket science. It is the principle that governs the motion of rockets and other vehicles in space. It is the reason why rockets can travel through the vacuum of space without any external force or medium to push against. Finally, when a rocket engine spews out propellant at high speeds from its nozzles, a magical transformation occurs. What was once just a static mass of metal and fuel becomes a dynamic entity, bursting with energy and motion. It generates a force, a thrust, something so powerful that it can overcome the gravity and propel the rocket into space. This thrust is the lifeblood of a rocket, the driving force behind every successful space mission. So, you see, there's so much more to rockets than meets the eye. They are not just objects, they are embodiments of human ingenuity and determination. As we continue to explore the final frontier, these rockets will remain our crucial companions, taking us further than we ever imagined. Ever pondered over the question, how do rockets work? Now, you not only know the basics, but also the depth and breadth of this incredible field. You've unraveled the magic behind these marvels of human achievement. So, when a rocket engine spews out propellant at high speeds from its nozzles, it generates a force, a thrust, propelling the rocket forward. Speaking of rocket engines, the real muscle behind every space launch, they operate on the principle of controlled explosions. A rocket engine mixes a fuel, perhaps liquid hydrogen or kerosene, with an oxidizer, typically liquid oxygen, inside a combustion chamber. This mixture, once ignited, combusts, producing hot gases that are expelled through a nozzle at high speeds. This expulsion of gases generates thrust, which gives the rocket the power to soar upwards, fighting against the force of gravity. But how do rockets achieve such incredible speeds and break free from Earth's atmosphere? Here, staging comes into play. Staging is a critical element of rocket design that allows rockets to achieve escape velocity and enter orbit. Rockets usually consist of multiple stages, each equipped with its own engines and propellant tanks. As each stage exhausts its fuel, it is discarded, allowing the remaining stages to continue the journey with less mass to accelerate. Strategically shedding weight during flight is crucial for overcoming Earth's gravitational pull and reaching the necessary speed to enter orbit. Once a rocket attains its intended altitude and velocity, it settles into orbit around a celestial body, like Earth or another planet. Orbital mechanics then come into play, maintaining a stable orbit and allowing satellites and spacecraft to carry out their missions efficiently. From launching satellites for communication and observation to exploring distant celestial bodies, rockets have drastically expanded our understanding of the universe and reshaped life as we know it on Earth. As the quest to push the boundaries of space exploration continues, rockets will remain our primary means of reaching the cosmos and unveiling its secrets. Thanks for undertaking this journey through the inner workings of rockets. If this video piqued your interest, remember to give it a thumbs up, share it, and subscribe for more content on science and technology. Until our next cosmic adventure, keep gazing at the stars.